Hello folks, and welcome to the channel, P20. In today's video, we're going to make the Linux folders easy to understand, so you can learn to navigate your system efficiently. I remember, when I first started with Linux, seeing folders like bin, sbin, mnt, it was really confusing. I had no idea what was the purpose of those folders. As a Windows user, I knew installed programs going into program files, but with Linux I didn't know where they were stored. But after learning what each folder's purpose was, it became so much easier. For example, once I realized bin stores common Linux commands, it made sense why I could run ls and cd commands from there, right after installing Linux. In this video, we will start with an overview of the basic parts of the Linux folder structure. Then we will look inside each of these folders, to see what's in them. I'll show you a few important Linux commands, and explain you how we can execute programs from anywhere in Linux. I'll try to explain the things, the best I can, in the simplest of terms. So, let's get started. The more you explore Linux and try different distributions, you'll notice that the directory structure is actually very similar, if not almost identical. That's because the Linux community have created a set of rules called Filesystem Hierarchy Standard. It is actually a standard. It tells everyone how the file system in Linux should look like, and how things should be organized. If you take a look at the root directory, which is like the starting point of everything, you'll find that most Linux distributions follow the same structure outlined by the Filesystem Hierarchy Standard. So, whether you're using Ubuntu, Fedora, or any other Linux distribution, you'll see that things are pretty much laid out in the same way. It means that, once you become familiar with the directory structure in Linux, you'll feel right at home, no matter which distribution you're using. It provides a sense of consistency, and makes it easier to navigate through the file system. Before moving on to the Linux directories, let me turn your attention to few key differences between Windows and Linux. In Linux, the / is used as a path separator in file and directory paths, while in Windows, the / is used instead. There are historical reasons for this difference, which are related to the development of Unix and Windows operating systems. We will cover them in a future video. In Linux, file names are case-sensitive. This is because Linux treats each character in a file name as distinct, and considers upper and lower case letters as different characters. This can sometimes cause issues when moving files between Linux and Windows systems, as Windows file systems are not case-sensitive, and may not recognize files with the same name but different capitalization. In Windows, files are stored in folders on different data drives like C, D, E. But, in Linux, files are ordered in a tree structure, starting with the root directory. This root directory can be considered as the start of the file system, and it further branches out various other subdirectories. The root is denoted with a /. The bin directory is traditionally reserved for essential executable commands that are accessible to all users. But it may also contain other types of files. In Linux, everything is a file. Even the commands we use are typically stored as executable files in specific directories. These files are commonly referred to as binaries, because they contain the compiled code that the system can execute. The "everything is a file" is a fundamental principle known as the Unix philosophy. It's a design philosophy that influenced the development of Unix-like operating systems, including Linux. It simplifies the system design, enhances consistency, and provides a flexible and powerful framework for managing various resources. So, now let's see what other contents we can typically find in the bin folder. Executable commands. The primary purpose of the bin directory is to store essential executable commands, that are available to all users of the system. These commands are typically considered fundamental utilities and are required for basic system functionality. For example, ls, cat, cp, mv, and rm. Linux commands can be grouped into two categories: built-in commands that are already inside the shell, and standalone executable files that are separate programs with their own powers. Both types of commands help us interact with the computer, manage files, run programs. Let me explain what are they. Built-in commands are an integral part of the shell itself, and do not require a separate executable file. They are executed directly by the shell. Some common built-in commands in Linux include alias, cd, exit, export, source, and history. Standalone executable commands are stored as separate executable files in specific directories, such as bin, usr bin, or usr local bin. These files contain the compiled code that the system can execute. The bin directory stores the essential standalone executable commands that are available to all users of the system. Now let's go back to see what are the other types of files we can find in the bin folder. System utilities. Alongside the standalone executable commands, the bin directory may also contain system utilities, or tools that are used for system administration or maintenance tasks. These utilities are typically standalone executables and are accessible by all users. For example, the systemctl tool that is used to manage system services, command line utilities such as ping, utilities such as mount, and ssh. Non-executable files. While the majority of files in the bin directory are standalone executables, there may be a few non-executable files present as well. These non-executable files might include symbolic links or shortcuts to executables located elsewhere in the system. Symbolic links in bin directory ensures that essential executables are easily accessible and available to all users. This technique helps to maintain a standardized directory structure. Now, let's see what is this X11 folder. The X11 directory contains executable binaries related to the X window system, which provides the graphical user interface, GUI, for Linux desktop environments. Specifically, it contains the X11 server, which is responsible for drawing windows and handling user input. In modern Linux distributions, the X window system is commonly replaced by Wayland, which is a newer protocol for displaying graphical content. However, many legacy applications and desktop environments still rely on the X window system and its associated binaries. When you navigate to the bin directory, you can observe the X11 appears to have an infinite number of subfolders that are also named X11. The cause of this repetition is related to the symbolic links and the way the X11 directory is structured. It is possible that one of the symbolic links in X11 folder is pointing back to the same directory, creating a loop. This can cause this infinite repetition you are seeing here. So in summary, the primary purpose of the bin directory is to store essential executable commands that are available to all users of the system. Users can execute these commands from anywhere in the system without explicitly typing the path. By default, the bin directory is included in the path variable in Linux. This means that when you enter a command, the system automatically searches for it in the bin directory, among other directories in the path. To view the path variable in Linux, you can use the echo command. It is important to note that file paths might vary slightly based on the specific Linux distribution in use. The path variable consists of a list of directories separated by colons. When executing a program, the system checks these directories in a left-to-right order. If you want to display the directories in the path variable on separate lines, you can use a more improved command like this. It replaces the colons in the path variable with new line characters, resulting in each directory being displayed on a new line. By the way, if you find this video useful, please leave a like and subscribe to the channel, so we can know, and YouTube knows this is useful for you, and we will keep doing more of these. Next is boot. The boot directory is like a special place in Linux, where all the important stuff related to starting up the operating system is stored. It's kind of like the starting point for Linux when you turn on your computer. Here's a bit more about it. Inside the boot directory, you'll find files like the kernel image, bootloaders, and configuration files. These files are essential for the computer to know how to start up Linux properly. They work together to make sure everything runs smoothly. Linux kernel is the core of the operating system. It's responsible for managing the computer's hardware, memory, processes, and all the other stuff that makes Linux work. It's like a barrier or bridge between the applications we use. It helps applications talk to the CPU, memory, and devices like video cards, so they can work properly. Different Linux distributions like Ubuntu, Fedora, or Debian all use the same Linux kernel, but they may have some differences. Some distributions may choose to use slightly older versions of the kernel to ensure stability and reliability, while others prefer to use the latest and greatest versions for the newest features and improvements. So, the Linux kernel is like a big program that helps applications make use of the computer's hardware. It serves as a bridge between applications and the inner workings of the computer, allowing them to work together smoothly. Now, the kernel image is a special file that contains the Linux kernel. It's like a snapshot of the kernel at a specific point in time. This file is usually called vmliners or something similar, and it is stored in the boot directory. Inside the kernel image, you'll find all the instructions and code that the kernel needs to run properly. It's like a recipe book for the kernel, telling it how to handle different tasks and communicate with your computer's hardware. When you start up your computer, the bootloader loads the kernel image into the computer's memory. Once the kernel image is in memory, it can start running and take control of the whole system. Bootloaders. Bootloaders are small programs that help your computer start up the operating system. They are responsible for finding the kernel image file and loading it into memory. Popular bootloaders in Linux include Grub, Grand Unified Bootloader, and Lilo, Linux Loader. Next is configuration files. In the boot directory, you will also find configuration files that tell the bootloader how to start up Linux. These files contain information like which kernel image to load, where to find it, and any special settings or options that need to be used during the boot process. The reason why the boot directory is separate is for security. By keeping the essential boot files isolated in one place, it helps protect them from accidental deletion or modification, which could cause your computer to have trouble starting up. So, the boot directory in Linux is like a special folder that holds important files for starting up the operating system. It contains the kernel image, bootloaders, and configuration files that are essential to get Linux up and running when you turn on your computer. I don't want to make this video too long, so I'm going to split this video into few videos. In the next videos, we are going to cover the rest of the directories. Thank you so much for watching. Please make sure to hit like and subscribe buttons. I'll see you in the next video.